Okay, we're going to talk about S8C Chi-squared test for independence, part 2. Okay, and as I mentioned before, if you're going to do your IA using surveys, this is super, super important. Okay, so we're going to take our data from the previous assignment, which was S8B, Chi-squared test for independence, part 1, and we did investigation 3, and we found this data after we tallied up all these points. Okay, so I'm just going to write these values down right here. So we had 10, 7, 16, 9, 13, and 5. Okay, those were the observed frequencies. Okay, now the expected frequencies were the values that we got here of, let's use a different marker here. We had 10.45 is already written, 11, 11.55, 8.55, 9, and 9.45. Okay, and then we had to subtract these. So 7 minus 11 is negative 4. 16 minus 11.5 is 4.45. 9 minus 8.55 is 0.45. 13 minus 9 is 4. And 5 minus 9.45 is negative 4.45. Okay? Now, I'm going to take these values and I'm going to square them. And one of the reasons that we're squaring them is so that we end up with positive values, because we're eventually going to add all these things together, and it's going to tell us how far this expected data, how far it's out of line or in line with our observed data. Okay? So so I'm going to take these values, I'm going to square them, and okay, 4 squared is 16, 19.8025. Let me get my calculator here. .45 squared is 0.2025. 16, 19.8025. All right. And I'm going to take each of these values and divide it by, I'm going to take all of these values here and divide it by these values here. Okay. Oh, that's hard to see. 11, 11.55, 8.55, 9, 9.45. Okay, that makes it easier to look at. Okay, so I'm going to take these yellow values and divide it by the blue values. So 16 divided by 11 gives me 1.4545. 9.8 divided by 11.55 gives me 1.7145. 0.2025 divided by 8.55 gives me 0.0234. 68. 16 divided by 9 gives me 1.7777. And 19.8 divided by 9.45 gives me 2.0955. Okay, so I'm going to take these values and I'm going to add them all together. So we've got 0.1937 plus 1.4545 plus 1.7145 plus 0.02368 plus 1.77777 plus 2.0955, and I'm going to get 7.2597. Okay, so, and that is the value here. And as we learned in our previous lesson, that this value gives us our chi-squared value. So this is our chi-squared calculated value. Okay. Now, so one of the first questions, and we'll be talking about how to use this in just a minute. So one of our first questions is, so for 5% significance level, the critical value is chosen, so the probability of the test statistics being greater than the value of the two variables is independent at 5%. Okay, so if this, so we need to look at our critical value table, and at 5% and 1%, if you look at our table here, at 5% our values are lower than at 1%. So basically what's happening is if your calculated value is bigger than the value on the reference table, then you know that we're going to reject our null hypothesis, saying that so we're going to then you would know it's not independent. So at a 1% significance, notice it's a bigger value than at 5%. Basically, you have to get a higher chi-squared calculated value for 1% significance, because this is saying that your data is so accurate that it's definitely independent or dependent, or not independent, independent or not independent. So will the critical value be larger for 1% significance than for 5% significance? And basically, for 1% significance, the critical value is larger. Okay. So So these critical values that I just showed you on this table are not ever going to be, you're never going to have to look at a table. During the IB test, they will always tell you what the critical value is. So for this example, for 2 degrees of freedom at 5% significance level, you know that the critical value is 5.991. Now, if I wasn't given that information, 2 degrees of freedom, right here, 5%, we can look at our reference table, and we know that that's 5.99. Okay, so this critical value here, I'm going to compare this critical value to the calculated chi-square value. Okay. And So we can see that 7.2, let's call it 7.26, we can see that 7.26 is greater than 5.991. So because our calculated value, so the chi-squared calculated value is bigger than the critical value, I can determine if our chi-squared calculated value is bigger than the critical value, then we reject the null hypothesis. So because of this, we reject the null hypothesis. If we reject the null hypothesis, that means we accept the alternative hypothesis. It should be 1. And the alternative hypothesis is so we're rejecting the null hypothesis. The null hypothesis is that preferred racket game is independent of gender. So the alternative hypothesis is that preferred racket game is not independent of gender. So therefore, preferred racket game is not independent of gender. Okay, so whenever the calculated chi-squared value is bigger than the critical value that you get from the table, we reject the null hypothesis. And so that means that people who are playing the racket game, their interest in playing racket game is not independent of gender. Now, that does not mean that it's dependent on gender. It just means that if you are a guy, you might prefer to play squash, but it doesn't mean because you are a guy you play squash or you prefer squash. It just means, it doesn't mean that it causes you to like squash more than the other. It just means that it's not independent. You need to think about that for a minute because it's a tough thing to put your mind around. Okay, so as I mentioned in class, this part here is so important. So basically, if your calculated value of chi-squared is smaller than the critical value, we accept the null hypothesis. So the null hypothesis is the two things that we're comparing is independent. Okay, if your chi-squared calculated value is greater than the critical value, we reject the null hypothesis. The alternative hypothesis, if we reject the null hypothesis, we accept the alternative hypothesis, which just says the two things that we're comparing is not independent. Okay. So using the graphing display calculator, we get this value. So for just as a reminder of how to do that, we've got our data here. I'm going to hit second and the x to the -1 to get matrix. I've got a 2 by 3 matrix here, so I'm going to go over to edit. I hit enter and I put in the data. Oh, it's already in there. Okay. Then I hit stat. I arrow over to tests and I scroll down to to chi-squared. Okay, I hit enter. It says that my table is in table A. It's going to calculate the expected value for me if I didn't already do it. So then I go to calculate, I hit enter, and it tells me my chi-squared value is 7.08. Okay, and that's what we wrote here. Now, when we did this on the previous page, we got 7.259. Okay, well, it's not exactly the same, is it? But this little bit of difference didn't really matter when I was looking at the critical table, did it? The critical table, this was clearly larger than the value from the critical table. So even if you don't get exactly the right value, and this is probably a little different because of rounding, so even if it's not exactly the same, it still did not change whether or not to accept or reject because it was so much greater than the critical value. Okay, so the p-value here is 0.289. Okay, so if I wanted to compare this to a 5% significance, this is much smaller than 5%. So this is also saying that we do not accept the null hypothesis. So whether or not I'm using the critical value and the chi-squared value, or if I'm using the p-value and I'm comparing the p-value to the percent significance that I'm working with, both ways of comparing it with p-value or chi-squared value tell us whether to accept or reject the null hypothesis. So if your p-value is greater than 0.05, if we're dealing with 5% significance, then we accept the null hypothesis. If the p-value is less than 0.05, then we would reject the null hypothesis. Now I'm using 0.05 for when we're talking about 5% significance. Okay, so how would you use the results of the chi-squared to determine whether the two variables are independent? So you compare the chi-squared or the p-values to the significant level. So comparing it to the critical value or comparing it to the percentage for the p-values. Okay. All right. Let's talk about this carefully because this. Okay. Question A. Write down the null hypothesis. Okay. So we've got 80 people, and they were asked their favorite genre of music, and here are the results. So I'm comparing gender and genre of music. So my null hypothesis is favorite music genre is independent of gender. The alternative hypothesis is that favorite music is not independent of gender. So, as I mentioned before, the null hypothesis is always the one thing is independent of the other thing. And the alternative hypothesis is always the one thing is not independent of the other. Okay. If I had switched gender and favorite music, it would still mean the same thing. Gender is not independent of favorite music. It would still be the same. Okay. Question B. Show that the expected value for a female liking pop is 21. So basically, what I'm going to do is we know that there are 42 females. So I've got 42 over 80. And the probability of liking pop is 40 over 80. So the probability of being female and liking pop is 42 over 80 times 40 over 80. And so the expected value is when you multiply how many people are there total. There's 80 people. So if I multiply 80 people times the probability of being female and liking pop, and that will tell me how many people we expect to be female and liking pop. So this is the number of people in the experiment. This is the probability of being female, probability of liking pop. Multiplying all of those together, and we will expect that 21 people are female and like pop. Now, when we look at our experiment, there was 22 people that were female and like pop. So pretty close to the same. Okay, how many degrees of freedom are there? So you take the number of rows minus 1 times the number of columns minus 1. So I've got two rows, right, male and female. So I'm going to have 2 right here. I've got 1, 2, 3, 4 columns, right? So I'm going to have 4 minus 1. When I'm counting the number of rows and number of columns, I don't count the total rows, just male, female, pop, classic, folk, and jazz. I'm not counting the total rows. Okay. And we get a degree of freedom of 3. Okay. Find the value of chi-squared. So if I'm plug this into my calculator, let's just do it. Okay. So second matrix, edit, 2 by 4. Okay, so now I'm going to hit 18, enter 9, enter 4, enter 7, enter 22, enter 6, enter 7, enter 7, enter. Okay, so now I hit stat, arrow over to tests, go to chi-squared test, I hit enter, 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 enter. And now it tells me, okay, I was right. My degrees of freedom are 3. My chi-squared value is 1.62. And my p-value is 0.654. So 1.62 is my chi-squared value. And my p-value is 0.65. Okay, so now I'm going to compare these values here to, okay, let's compare chi-squared 1.6 to the critical value. The critical value, you were told, is 11.345. So if I compare 1.6 calculated value to 11.345 value, you can see that the calculated value is less than the critical value table, and so if my calculated value is less than the critical value table, we accept the null hypothesis. So we accept the null hypothesis, and so favorite music is independent of gender. I could also look at my p-value, which we calculated to be 0.65, and comparing that to 1%, which is 0.01. So this is also greater than 0.5, and so if I go back to here, if p is greater than the significance, 0.01, we accept the null hypothesis. So for both ways here, because this is greater than 0.01, in both cases we accept the null hypothesis. Music is independent of gender. Okay, let's do the next one together. Okay, so they gave you heights of dogs and their weight. So, to figure out the mean weight of a dog, we add all the weights of the dogs together and divide by 50, and we found our mean weight of the dog. Okay, so what I did here was so we've got different categories. If a dog is shorter than 52 centimeters, then it's called a pocket dog. And if the dog is between 42 centimeters and 50 centimeters, it's called a standard dog. And if the dog is between 50 centimeters tall and 58 centimeters tall, then it is called an XL. Okay, so I looked at all the pocket dogs, which are in yellow, and I saw that, and I looked at the weights. So there was about 13 of the pocket dogs that were less than 44.96 in weight, and then there was 3 pocket dogs that weighed more than 44.96. Now, standard dogs. There was 8 standard dogs that weighed less than 44.96, and there was 9 standard dogs that weighed more than that value. And then for Excel, there was 3 dogs that weighed less and 14 dogs that weighed more. Okay, so just for calculations ease, I got my totals here. Okay, so my null hypothesis is that class of dogs is independent of weight. Okay, so we've got our different classes and we've got our weight. And our alternative hypothesis is that class of dogs is not independent of weight. So, okay, degrees of freedom. I've got my number of rows, which is 2, and my number of columns, which is 3, and we end up with a degree of freedom of 2. Okay. Show that the expected number of XL dogs that weigh less than the mean is 8.6. So first of all, I got the probability of being an XL dog is 17 out of 50. So I wrote that down, 17 out of 50. The probability of being less than a mean dog is 24 out of 50. So this is probability of having an XL dog. This is the probability of a dog being less than the mean in weight. Multiply those two together. This is the probability of being an XL dog that is less than the mean of weight. And I multiply it by 50 because there's 50 dogs in the experiment. And multiply all that together and we get 8.16. Okay. If I put this into the calculator, I get these chi-squared values. Okay, so comment on your answer. So for 5% significance, why did I choose 5%? It says it right here. Let's compare it to 5% significance. Okay, notice they didn't give you the critical value, did they? So when they don't give you the critical value, and let's just say it's the IB test, then I'm going to be looking at the p-value. So here's the p-value that we calculated, 0.00125, and this is smaller than 0.05, which is 5% significance. I read it as a decimal. So since this is smaller than this, we do not accept the null hypothesis. So basically, the type of dog and its weight are not independent. And that kind of actually makes sense when you look at it, because doesn't it look like that the pocket dogs, there's more of them that are smaller, and the XL dogs, there's more of them that are bigger. So it does seem that there is some sort of correlation between size of the weight of the dog and size of the dog. So it does seem like there's a correlation, which would mean that they are not independent. Okay, set up the contingency table. So I ticked off all these things, and I've got my observed data. Okay. So this is my observed data. Okay. Write down the null hypothesis. The null hypothesis is that favorite sport is independent of gender. The alternative hypothesis is that favorite sport is not independent of gender. Degrees of freedom is 2. This you get from the calculator. Okay, so you can calculate, you can either get these values from your calculator. So let's talk about how we do that. So on the previous example, I calculated the chi-squared. If I go over to second x to the negative 1 for matrix, if I wanted to view uh, matrix B, I hit enter here, enter, and then it gives me the values of what the expected results should be. Now this was for which question? These values should match. Well, they didn't ask you to do it. It was for this example too. But okay, well, let's just do this one anyways, right? So if I've got edit 2, 3, okay, 7, 10, 6, 9, 8, 10. Okay, and then I do stats, arrow over to tests, arrow down to chi-squared test, enter, enter. Okay, we've got our chi-squared and our p-value, which is what we talked about earlier. And now, if I didn't want to calculate these by hand, I could just take my values from the calculator. I do second x to the negative 1 for matrix. I go down to B, hit enter, enter, and now I've got my values for my expected value here. Okay. So in this example, my calculated chi-squared value is less than the critical value which they gave. So whenever the calculated chi-squared value is less than the critical value, we accept the null hypothesis. So favorite sport is independent of gender. I could have also looked at the p-values. The p-value here is 0.56. 0.56 is greater than 10%, 0.10. So for this reason, we also accept the null hypothesis that P supports our conclusion. And once again, I get this comparison and this comparison. You need to look at this part right here, and that will help you determine if to accept or reject the null hypothesis. Okay. You may want to hit pause and check your answers. Okay, for these, you may want to hit pause and check your answers. And for the last page, you may want to hit pause and check your answer. And I'll move it up now. You may want to hit pause and check your answer.